Hello everyone, welcome to the Learning Royal. Today, due to popular demand, we are starting a new series which is called Python Basic. So in Python Basic, we will cover the basics of Python. Every week, we'll be posting one video for this series. So let's begin. So week 1 agenda. What is coding? Why is coding important? Flowchart and basics of coding. This is basically what you're going to learn today after watching this video. So let's start with what is coding. Computers understand binary language, which is basically 0/1, 0 and 1. So you might have heard of it, and it's used a lot in computing. Humans speak in various languages, English, such as Hindi, English, Tagalog, Mandarin, and Spanish, etc. To translate our language to the language the computer understands, we need a programming language that can act as an intermediary. So some examples of these languages are C++, Python, and JavaScript. We're going to be learning Python, so make sure you pay special attention to that. So binary language is basically like a toggle switch. Each and every character in binary is either on or off, which is also 0 or 1. So it's basically a switch, each one of the characters. So why is coding important? Coding helps us translate the commands to the language that computer can understand. Computers' processing power and speed can be therefore used for solving complex problems. Many interfaces can be developed using computers or processor for automation of tasks and complex activities. Smart devices and IP-connected devices all have some sort of coding to run successfully. So let's read all the statements carefully. The first statement. Well, coding can help us translate commands from binary so we can understand it, and we can somehow tell the computer what to do, so it acts as an intermediary. And then the computer's processing power, you guys probably know this, the computer is very strong and can solve problems very quickly, unlike the normal human brain. So we can use the computer with the use of coding. Without coding, we won't be able to use the computer. And the third thing says, um, with coding, we can make many interfaces, basically softwares or hardwares, um, or processor for automation. So, for example, if you don't want to do something, if you want to, let's say it's a math problem, you can just feed it into a calculator, which is also a computer technically, and then the calculator will solve the problem. So number 4, this is the most important reason why coding is important. Without coding, we won't have all the devices we have today, and we won't be able to run it successfully. So that's the main reason. Now let's continue on to the next slide. So types of languages. So there are 4 types of languages: assembly language, binary, high-level language, and low-level language. So assembly language is like binary. So first, let's just start with binary because you guys are most familiar to that. So as we already know, binary is the language that is used by the computer. Example 0, 1. Okay. Assembly language is like binary, except instead of being base 2, it's base 16. As I mentioned here, it's in hexadecimal. So assembly language. The assembly language is the language which microprocessors use. The microprocessors are basically the processing unit inside your computer. So some processors, example, are Pentium, which is Intel, Celeron, 8085, 8086, etc. So there are many types. Now there are 2 types of languages also. Other 2 types of coding languages, which are high-level language and low-level language. So high-level languages are human-friendly programming languages, meaning that they often include words from human languages like English to make the language more easy to understand. Some examples of this are JavaScript, Python, and C++. The low-level language, on the other hand, is machine-friendly, meaning that the machine has it easier to read, but it's harder for humans to read it. So these are some of the older languages like Fortran, C, and Java. continuing on. So we will use the term algorithm a lot in the next few weeks. So algorithms are basically step-by-step procedures of solving a problem statement, or step-by-step procedures. I might have not included in here, but step-by-step procedures of a program. Okay, so this is the first step of coding. So example, this is an example here. Algorithm for sum of two numbers. So step 1, it will start. Step 2, it will ask for the input A and B, two numbers. Step 3, it will add A and B and store in C. Okay, and step 4, it will display C. And then step 5, it will end the algorithm. So this is an algorithm used for summing two numbers. So Flowchart. Well, flowchart is basically an algorithm, but it helps you make your algorithm more organized. Okay, so to make code, you have to break down the problem in the smaller steps logically. Flowchart is a pictorial representation of any mathematical or logical solution. These are the objects in the flowchart. So there's start, stop, process, decision, connector, and input-output. So this is a sample flowchart. As you see, start and stop, which is start and end, both have this oval around them. Okay, and then any input is always going to have this input slash output is gonna have this parallelogram. Every decision is gonna have, not decision, I mean every connector, like summing and like storing the sum of the two numbers in a variable. These two, this is a connector. And decision, it's not really shown here, but it might. Yeah, so decision, as you can see here, it's this diamond shape, which is like an if or if then statement. Okay, so this basically, and this chart basically summarizes the elements of the flowchart. So arrows are used to connect things, start or end. I already mentioned all of them. Well, you can read if you want. Okay, we'll continue. So storage units. There are many types of storage units in a computer language, like bit, bytes, KB, MB, etc. You might have heard of these already because they're often used in daily life. So information storage. So any 0, 1, or any character in binary is a bit. 8 bits, meaning 8 binary characters, make a byte. 2 nibbles make up 1 byte, meaning that each nibble is 4 bits. A byte is also known as an octet because the byte has 8 bits. Now 1024 bytes make a kilobyte. Now you might ask, why 1024? Because these numbers are always 2 to the power of something, and 2 to the power of 10 is 1024, so they used 1024. So 1024 bytes make a kilobyte, 1024 kilobytes make a megabyte, and 1024 megabytes make a gigabyte, and so on. So continuing on, their bits and bytes chart. So these are the abbreviations, and then there's so many types of bytes, as you can see. There's a kilobyte, megabyte, gigabyte. We talked about this, and terabyte, 1024 GB, and the pattern continues with the others like petabyte, exabyte, zettabyte, yottabyte. So they keep on continuing. So as you can see, and there are many types of storage units. And then how to convert a decimal number into binary. This is a major problem that humans face in daily lives, because sometimes the computer just responds in binary, but you should be able to know how to answer that. So for example, let's solve 93 in binary. So how would you say 93 in binary? You'll subtract the highest power of 2 from 93, which is 64. So that's 93 minus 64 equals 29. And then you'll subtract the highest power of 2 lower than 29 from 29. That will be 16. That leaves us with 13. Now you'll subtract the highest power of 2, which is lower than 13, which is 8. So that continues 5, and 5, the lowest and the highest is 4. So 4, that's left. Now we are left with 1, which is 2 to the power of 0. Now now we can do it in binary. When we're left with 1 or 0, we can start our binary conversion. So first, let's write all the powers we used, not used, like, and from 0 because we have it at the end, to the biggest power we used is 2 to the power of 6, which is 64. We used it and to subtract 90 from 93. Now, if we subtracted these powers, any of these powers, we will write a 1 on top of it. Like we subtracted 64, we write a 1. But we didn't subtract 32, so we write a 0 there. So this pattern continues, and our answer becomes this binary number, as you can see, 10111101. This is only 7 characters, because so it's not the full byte, but it's still a number. So in a byte, it'll just have another 0 in front of it if it was to be a byte. Okay, so these are some practice problems. You guys can take some time to solve this. You can pause the video because I'm going to continue on. Okay, I'm going to continue. So how to convert binary to a decimal number. This is the opposite of what we just did. So what we're gonna do, and just like before, we're gonna draw our chart. So we're gonna draw the chart 2 to the 0 to 2 to the 64. In this chart, we're gonna have the amount of digits that this number has. Because this number has 7 digits, we have so from 2 to the power of 0 to 2 to the power of 6, which is 7. 7 digits basically. 1, 2, 3, 4, 5, 6, 7. And we'll just write the number on top. Which is 1, 1, 0, 1, 0, 0, 1. Now what are we gonna do? We're gonna add all the numbers if they have a 1 on top of them. Like 64 has a 1 on top, so we'll add that. And 32 has a 1 on top, so we'll add that. So we'll add all of them. And eventually, after we're done adding all of them, we get that the number is 105. So that's our answer. So these are 3 other practice problems. So you can use that and take some time. Okay, I'm gonna continue. So these are letters in binary. So letters, because they can't be solved for in number form. So they already have pre-made binary codes, which are 1 byte each. So if you want to reference to this, you can reference it later on. Each of the characters are also included as well. So let's continue. Practice questions. These are some questions that we can solve right now. So what is RAM? RAM is basically random access memory. So what basically is RAM, you might ask? Well, RAM is basically, as I told you, random access memory, which can be written or read. So that means you can edit the information also. Now, question number 2, what is ROM? ROM is read-only memory. As the name suggests, it can only be read, not edited. Number 3, how many bits are in a nibble? So as we learned earlier, since there are 2 nibbles in a byte, and there are 8 bytes and 8 bits in a byte, there are 4 bits in a nibble. How many bytes are in a kilobyte? As we learned earlier, there are 2 to the power of 10, or 1024 kilobytes, 1024 bytes in a kilobyte. So that is it for this week's lesson. I hope you enjoyed your basics of computer science lesson today. This was just the basics, like the basic stuff. We haven't gone into any coding yet. We'll get into that next week. Stay tuned. Please make sure to subscribe, share, and like. Thank you.